Hi, welcome back. In the last video, we looked at our Pythagorean theorem. We switched the order of the hypothesis and the conclusion to get the converse. If a squared plus b squared equals c squared, then you know your triangle is right. And we tested two triangles to see if they were right triangles. Remember, your longest side is the side you're going to check to see is that a hypotenuse. That's going to go in for C every time. Your longest side will go in for C. If a squared plus b squared, if the two sides are equal to c squared, then you know you have a right triangle. If they're not equal, then you do not have a right triangle. But we left off when in the last notes asking the question, can we use the converse to tell if a non-right triangle is acute or obtuse? So this angle in the corner that wasn't right, can I tell, is it less than 90 or is it more than 90? Okay? So when we want to classify a triangle that's not right as either acute or right, we're going to look at the biggest side and pretend it is a hypotenuse. Okay? And then we're going to apply the converse. In an acute triangle, the converse will reveal that the c squared is too small, and that should be squared, is too small to be a hypotenuse. In obtuse triangles, the converse will reveal that your c squared, it should be squared, is too big to be a hypotenuse. Okay, so let's look and see exactly what that's talking about. When I have an acute triangle, let me sketch myself a little triangle here. If I have an acute triangle, all these angles are less than 90, okay? If I pick a side and I say it's the hypotenuse, then it would have to be open, it would have to be longer for these two sides to make a right triangle. So my acute triangle, it's not going to be open all the way to 90, so that means this side is going to end up being shorter, because we know that the biggest side in a triangle, the bigger the angle is, the larger it is open. We talked about that hinge theorem. The wider you open the door, the bigger the opening is. Okay, so the bigger the angle at the hinge, the bigger the side. Okay, whereas in an obtuse, if I take those same sides and I look at an obtuse triangle, if this had been a right triangle, I'd have a shorter hypotenuse, but this side is going to be way longer when I test it as a hypotenuse. Okay, so your c squared is going to be too big to be a hypotenuse. Okay, let's look and see how exactly that looks when you're applying the converse. Okay, so let's look at this first picture. I can tell this first picture definitely looks obtuse. Let's see if we can prove that it's obtuse. When I look at my 10, my 8, and my 14, the side that would have to be my hypotenuse, we're going to pretend it's right. I know it doesn't look like a right triangle, but we're going to pretend it's a right triangle. When I look at this one and I pretend it's right, C would have to be the 14. So we're going to put that in for my C because it's the biggest number, right? 10 and 8 are both smaller. So if this was a right triangle, it doesn't look like it is, but if it is, C would be my hypotenuse. So I'm going to test 10 squared plus 8 squared. And I'm going to say, does that equal 14 squared? Okay, so in my calculator, 10 squared plus 8 squared. And remember, this calculator is just the one that comes with CMS SchoolNet. You just search with the word calc as your test code. All right, so this side is 164. And then my 14 squared is 196. Remember, this is a squared plus b squared equals c squared, right? This is a squared plus b squared, and this is my c squared, where this is supposed to be a hypotenuse, right? But when I look, they're not equal. This side is too big to be a hypotenuse, right? 196 is too big to be a hypotenuse. So that means this triangle is definitely obtuse, because this angle is open too wide to be 90 degrees, because this side is too long. So this angle is open too wide. Okay, let's look at the next one. When I look at the next one, I've got 25, 24, and 7. So when I look at that, the biggest one that's going to go in for my C is going to be this 25, right? That's going to be the biggest number. So I'm going to put that in for C, and I'm going to test these two, 7 squared and 24 squared. And how do those correspond with 25 squared? Right? Is it equal? Are they right? Is it greater than? Is it less than? What do we have? Okay, and notice it's kind of backwards. We have a less than symbol, but it's obtuse because you look at the right-hand side and see it's too big. Okay? All right, so 7 squared plus 24 squared, 7 squared plus 24 squared gives me 625. And then 25 squared gives me also 625. So these are equal, which means even though this triangle does not look right, to me it doesn't look right at all, this is a right triangle. And that's why we can never trust our eyeballs in geometry pictures, because unless it says this picture is to scale, you can't assume that this picture is acute, okay? So this is really a hypotenuse, which means coming back from it, this is really a 90-degree angle, even though it doesn't look like one, okay? All right, let's look at this third picture here. When I look at the third one, I need to pick which one's going to be my hypotenuse. So when I look 16, 21, 24 is my biggest side, so I'm going to test that as my C. 16 squared plus 21 squared. How does that compare to 24 squared? So 16 squared plus 21 squared equals 697. And 24 squared is 576. So they are not equal, right? They're not equal, which tells me, since they're not equal, my 697 is bigger than my 576. So this side that's supposed to be my C, that's supposed to be my hypotenuse, this side is supposed to be 697, but it's too small. Which means this triangle is actually an acute triangle. Okay? All right, and then my last one over here, last but certainly not least, let's go with red. Why not? Okay, 15, 8, and 17. So when I'm looking at these, my 17 is my biggest number, so that's the one I'm going to test as C. And of course, this looks almost identical to this picture, but different numbers. So let's see. 15 squared plus 8 squared. 15 squared plus 8 squared. Is that equal to 17 squared? So let's see. 15 squared plus 8 squared. 15 squared plus 8 squared gives me 289. 17 squared. 17 squared also gives me 289. So even though, again, this picture does not look even close to right, the two sides are equal, which means this is a right triangle. This 17 is indeed a hypotenuse, which means the angle back across from it is a right angle, even though it doesn't look like a right angle. It is a right angle, okay? So when they're equal, I kind of think of this kind of like Goldilocks and the Goldilocks and the 3 bears. I had the wrong number of bears, right? So if it's too big, we're obtuse, just right, and we're right. Too small, we're acute, and again here, just right, we are right. So is it too big, too small, or just right, like Goldilocks, okay? There's one last type of problem you'll see that I want to squeeze on this video, and then we'll have this lesson done and ready to put in the books. Okay, can the following squares form a right triangle? We see this a lot. Notice it tells me that these are indeed squares. Okay, so since I know they're squares, I know that they're making right angles, and I know the sides, all the sides across are all the same. And when it says, can they form a right triangle, it means if I take the corners and I put them together, I slide them in together, right? I slide them in together, and I make a little triangle here. Is that triangle going to be a right triangle? So we're going to test this using the converse. Since I know opposite sides, or all the sides in the triangle or in the square are the same, I know all 4 of these sides are 9. all 4 of these sides are the square root of 19, and all 4 of these sides are 10, I know what these are, right? This is 9, the bottom is the square root of 19, and this diagonal piece here is 10, okay? We're going to test this. A squared plus b squared, does it equal c squared? Which means I need to know the biggest side. And it looks like 10 is my biggest side, but I'm just going to check that square root of 19 and make sure that's not bigger than 10. I'm pretty sure it's not. Nope, it's teeny. It's 4.35. Okay, so it's teeny, teeny, teeny. This is my smallest side, just like it looks. Okay, so this is what I'm going to test as my c squared. Okay, so when I'm testing, I'm going to test the 10 as my c. So let's see. I'm going to do my first one, 9 squared, plus the square root of 19 squared. Does that equal 10 squared? Okay, I'm going to type this in my calculator just like I see it. 9 squared plus the square root of 19. Now here's the issue. You see how my cursor is still underneath that square root? If I want the square outside the square root, to get outside the square root, I'm going to hit the little right arrow above the clear button. And notice it stops my square root there, and I can now hit my x squared, and it looks just like it does here on my paper. Okay? And when I do that, I get 100, which is great because I know this 100 times itself, 100 squared, is also 100. So these are equal, which means, can the following squares form a right triangle? Yes. Yes, they can. Okay, let's do the same thing and check the second one. Okay, so when I go to check the second one, again, we're going to do the same thing. Will the 3 sides, when I push them in together, will they make a little right triangle here? Okay, 16, 3, and 34. 34 is my biggest number, so that's going to get tested in for my C. 16 squared plus 3 squared, is that equal to 34 squared? So let's see, 16 squared plus 3 squared is 265, and 34 squared is much bigger, 1156. So do these make a right triangle? These are not equal. My c squared side is way too big. So can the following squares form a right triangle? My answer here is no. These might not even be able to form a triangle at all. Remember, thinking way back, in order to form a right triangle, my third side has to be in between the sum and the difference of the other two. Well, the difference here would be 13. The sum would be 19. These don't even make a triangle, let alone a right triangle, right? Because 16 plus 3 is only 19. This 34 is way too big. Okay, so these don't even make a triangle. Okay, so my answer here is definitely not a right triangle. This one, yes. Okay, all right, so there is using your Converse to be able to identify whether a triangle is right, acute, or obtuse. Just applying that Converse and doing like a little Goldilocks in the 3 bear situation. Too big, too small, or just right. Okay, thank you so much for watching. If you have any questions, please make sure you check with your teacher during sync time or after sync time during your remaining class time for tutoring. Thank you so much for watching.